Welcome to this video on algebraic fractions. Okay, now what we're going to look at here is on the left we have four algebraic fraction expressions that we have to simplify as far as we can. Okay, and on the right we have an algebraic fraction equation that we got to solve. So we'll look at the questions on the left first, and during these we will come across several algebraic techniques that you need to be familiar with that will come up in A-level maths quite a lot. So in the first one, I'm spotting on the top line on the numerator that I have the difference of two squares. Okay, because x squared and 1 are both square numbers, and that's why it's called the difference of two squares, because there's a minus sign between them. And if you factorize that, this is what you get: x minus 1 times x plus 1. Okay, and underneath you should just simply copy the denominator as it is, which is x minus 1. And at this point, hopefully you will have spotted that the numerator and denominator can cancel with these terms here, the x minus 1s. So I just literally put a line through here and here to show that I've cancelled them out, and that leaves me with not even a fraction but just the expression x plus 1, and that's the answer. Okay, right, second one. This time we have two fractions with different denominators. In algebra, to find the lowest common denominator, you just multiply the two denominators together. So what I'm going to do is I'm going to write each fraction over the same denominator, which is going to be x times x plus 2. Okay, so to change the first one to have a denominator of x plus 2, I've got to multiply the numerator by x as well. So I'm going to have x brackets x plus 1, and that's going to be over x brackets x plus 2. Okay, so my denominator is x plus 2. And from that I'm going to subtract the other fraction, and the other fraction is going to have the same denominator. Okay, so all I need to do here is just make a copy of that and bring it across. Okay, so that's the same denominator, and in order to make that have this denominator, I've had to multiply the x by x plus 2, so I must multiply the numerator of this by x plus 2. So this fraction becomes x minus 1 times x plus 2. Okay, so I'm showing all my working out clearly, step by step, what I'm doing. Now, we can now write those two, we can combine them into a single fraction with the same denominator. Okay, so I'm going to do that next by putting a fraction line in here. Okay, and underneath that I'm just going to put the same denominator that I've already used. Oops, make a copy of that, and that goes there. Okay, and let's work on this. So I'm multiplying out the brackets as I go, so I've got x squared plus x. Okay, x squared plus x, and this is the bit you've got to be careful about when there's a minus sign rather than a plus, because what I've got to do is I've got to subtract the product of this. Okay, so I'm putting the whole of that in a big bracket, so it's x times x, which is x squared, just using FOIL, first, outer, inner, last. So there's the first terms. The outer is plus 2x and the inner is minus 1x, so that leaves me with just plus 1x. And the last term is minus 1 times 2, which is minus 2. Okay, now you've got to be really careful here because that minus sign applies to each term in the bracket. So this means minus x squared minus x and plus 2 because it's minus minus 2. Now if I work through that, what will it leave me with? Well, look, I've got x squared minus x squared. That's 0. I've got x minus x, which is also 0. And then I've got minus minus 2. And that's really important because that minus minus 2 is actually plus 2. So it becomes 2 over the same denominator, x times x plus 2. Well, normally when we simplify, we multiply out any brackets. We don't have to, but normally that's what we would do. So I'm going to write x squared plus 2x, okay, as the denominator, and that's my answer. Right. Okay, so let me just underline that. Now in the third one, we have two fractions multiplied together. So what I'm doing here is looking for opportunities to cancel and factorize as soon as possible. And I'm also going to write this out for you in full, just so you can understand the cancelling process. So I'm going to write the x squared as x times x. Okay, you don't have to do this in the real thing, but it just helps to explain what's going on. And all that's multiplied by, I'm putting a little dot instead of a multiplication, just as a shorthand. And I'm going to factorize out the 3 from here, okay? And you'll see why in a minute. So 3 lots of 2x minus y. Okay, and hopefully you can see where that's come from. Now underneath this, I've got, and I'm going to keep it as two separate fractions for the moment, although I could easily have combined these by now. Underneath this, I'm going to put the 2x minus y on the left-hand side, and all of that's multiplied, remember this is a multiplication here, by y times x. Okay, so y times x. Okay, so we look now for opportunities to cancel, and it's quite easy because there's a lot that you can do here. So we can take out the x and the x, we can take out the y and one of those y's there, and we can take out the 2x minus y and the 2x minus y. And that leaves you with a very simple expression, because you've just got on the numerator 3x, okay, and on the denominator you've just got y. And that's it. That is the simplified algebraic fraction of the original. Now, the fourth one here is two quadratic expressions in a fraction. And they wouldn't be asking you to simplify this unless it was possible to factorize the quadratics. So here we go. We're going to assume that they will both factorize. And the only way you can get 5x squared, because 5 is a prime number, is from two brackets containing 5x and x. Okay, and similarly on the bottom, the same applies. You're going to get 5x and x. If it doesn't factorize, then you wouldn't be able to simplify it. Now, what do we need to do to get this to work? Well, we're going to need a 6 and a 1. One of them has to be negative, okay, and it's got to give us the plus in the middle. So we're going to need the 6 here, okay, and we're going to need a 1 there, and that's going to have to be a plus, and that's going to have to be a minus, okay. And you can see that that works. If you multiply that out, it will give you this expression here. Now we need to do something similar here, and in fact it will work if we put another plus 6 there, but this time a minus 3. Okay, and we were kind of expecting something like that to happen, because as you can see, one of those factors here cancels with one of the factors here and leaves us with the simple or simplified answer, which is x minus 1 over x minus 3. Okay, because the other factors cancel out. There it is. And let me just cancel the other factors out. So that was that one and that one. Okay, next we go on to the algebraic fraction equation. Now I'll just reveal what I've done under that little blue rectangle over there. Okay, and I'm going to explain this in full by showing you the process I'm following, and then I'll show you how you would normally write it down. So if I just take this box out the way, what I've done is I've split this up into 3 fractions and left some space, okay, because I'm going to add things to the numerator and denominator. So what I'm going to do here is essentially I'm going to find a common denominator for all 3 terms here. That one, and the 14. The lowest common denominator is going to be 3x minus 1 times 1 minus x. So this is the process that's actually going on. So I'm going to write next to this 1 minus x, okay, and I would need to put brackets around here as well. Okay, that's very important because it would be wrong without those. But because I put the 1 minus x next to that, I must also put it on the numerator next to the 5. You see? Like that. And then extend the fraction line across. Okay. And then I've got my plus sign, which follows. And to make this second fraction have a denominator the same as the first, I've got to multiply this denominator by 3x minus 1, which means to keep the fraction the same, I've got to put a 3x minus 1 on the top next to the 2 as well. Okay, so that's fine. I've just done the same to the numerator and denominator of a fraction, therefore keeping it the same. And now I put my equal sign in, and of course it doesn't equal, well, it does equal 14, but I need the 14 to also be a fraction over this denominator. But this time I need to get the 14, which is currently over 1, I have to put a denominator of all of this in it. So I'm going to take this whole denominator. If I can just highlight, no, I can't do that, I have to write it, I think. So this 14 has to go over, okay, I'll put the fraction line in. So next to that 14, I would have to write 3x minus 1 times 1 minus x. And of course, the same would have to be on the denominator, 3x minus 1 and 1 minus x. Now, all of what I've written down is just to show you the process that I'm following. In practice, because I knew that I was making a denominator the same all the way through, I can simply say, well, if that's true, then I can strip off all the denominators and just write the top line only. So in practice, all I would have written down is this: 5 lots of 1 minus x plus 2 lots of 3x minus 1, okay, equals 14 lots of, now, 3x minus 1 times 1 minus x. Okay, so I've written this out to illustrate to you what's going on, but I wouldn't normally have written that step in because obviously it takes a lot of time and isn't really necessary. If you know what you're doing, you can go straight from that to that. Okay, now we process it step by step. So I'm just going to multiply out the brackets as we go. 5 minus 5x, okay, plus 6x minus 2. And that equals 14 lots of the product of those two brackets. If you multiply them out, the first term gives you 3x. The outer term gives you minus 3x squared. Okay, the inner term gives you minus 1. And the last term, minus 1 times minus x, gives you plus x. Okay. I'm just going to combine those two x terms together and also simplify this. 5 minus 2 is 3, minus 5x, okay, plus 6x is plus 1x, and that equals 14 lots of 3x plus x is 4x, minus 3x squared minus 1. Okay, multiply everything by 14. 3 plus x equals 56x. Okay, minus 42x squared minus 14. If I bring everything on the right to the left-hand side, I will get a 0 on the right, and it'll be a quadratic. Add 42x squared to both sides. I get 42x squared on the left. Okay. Take away 56x from the x I've got already. I've got minus 55x. Okay, and finally, add the 14 to both sides. I've got 17, and that now equals 0. Okay, and that's a quadratic. Looks very difficult to solve. Could be solved using the quadratic formula, but it will factorize. Okay, now it may not be very obvious to start with, but usually in these simplifying problems you look for a factorization. There is a clue. Because 17 is a prime number, okay, and because the number in the middle is negative, and this is positive 17, it must have come from minus 1 and minus 17. That's a certainty. So there's no question that those two numbers must appear in the factorization. The question is, what does the 42x squared come from? It could come from 6x and 7x, 14x and 3x, but in fact, to save a bit of time and a bit of inspection, it will show that it's 21x and 2x. Okay, and if you multiplied that bracket out, you would find that you would indeed get that quadratic equation there, which gives you the solutions. Because for that to equal 0, x would have to be the fraction 17 over 21. Okay, and for this bracket to be 0, x would have to equal a half. Okay, because 2 times a half is 1 minus 1 is 0, you see. So they're the two possible values of x that would solve that equation. Okay, so what does that actually mean? Well, it means if you replace the x in here with a half and the x in there with a half, added those two fractions together, that would come to 14. If you replace the x there with 17 over 21 and that x also with 17 over 21, that would also give you 14. But no other number that you put in for x would give you 14. Okay, so you've solved that equation. Looked quite complicated at this point, but usually in this kind of thing, they would give you a quadratic that will factorize. So always look for that first before you use the formula. Okay, and that is the end of that video. Hope that was helpful.